Okay, so functions. This is something that, this is one of those words that we math teachers use all the time, right? But a lot of times kids don't even know what they are. So let's try and break it down. A function is basically just a relationship between two sets of numbers. But the thing that has to be true is that everything in the domain, which is really just your x values, right, can only go to one thing in the range. So for example, your age, you can only be one age at a time, right? You can't be 14 and 19. You're one of the two, right? You are one age. However, I'm sure a whole bunch of you in this class happen to be the same age. So it doesn't matter if there's 6 of you that all happen to be 14 or 15 or 16 or whatever it is, but you yourself could only be one age. So that represents a function. Every person in here has one age. But if multiple people in here have the same age, that's fine. It doesn't matter. Okay? So functions are basically where everything in your domain, every x value, only has one corresponding value in the range or its output. Okay? So one way to describe functions, every input or x value has exactly one output or y value. Okay, so we just use the example of your age, right? You have one age, so you're an x value and your output would be your age. You can only have one age. It doesn't matter if, all of you happen to be the same age. That's fine. That could totally happen. But you can't be more than one age at a time. That would not represent a function. That would break. Okay? So let's look at what that might look like in math. Okay? If I gave you, I like to start off with what's called a mapping diagram. Mapping diagram. And what we do in the mapping diagram, I literally take, usually it's a bubble or a rectangle, and I'm just going to list a bunch of x values in there. I don't know, -3, 7, 0, 1, and then I'm going to have a bunch of y values. And again, they could be whatever you want them to be. A half, -9, 6. Let's say it was that, okay? And then, if I wanted to show the relationship between these x's and y's, literally all I do is draw an arrow. So let's say when I plug in -3 into my function, it spit out a 6. Okay, great. When I plugged in a 7, maybe it spit out a -9. When I plugged in 0, maybe it also spit out a 6. And when I plugged in 1, maybe it spit out 1/2. This does represent a function because everything in the x section only goes to one thing in the y. So in other words, if each of you were represented here, right? So if this were Pablo, this were Juliana, this were James, this is Tyler, they only have one age. It just so happens that these two are the same age. That's fine. Right? That can totally happen. So yes, this is a function. Woo! Hello! Oh, what a happy day. Thank you so much.
You're very welcome.
Have a good day, you guys. Okay. So, sorry, let's pick up where we were. This represents a function because each x value only goes to one y value. It doesn't matter if two people happen to go to the same y value. That doesn't matter. It just matters that everybody in here is only going to one place. So let me show you an example of one that's not. I'm going to do another mapping diagram over here. Bless you. I can even use the same numbers. So this time, let's say -3 went to a half, but it also went to -9. That's where now it's broken. Because now I have one x value that's going to two different places. That's impossible. That's one person having two different ages. That can't be. So it doesn't even matter what the other ones are doing. I don't know. I'll just draw the arrows just to finish it out. And let's say maybe both of those go to -6. But since the -3 is going to two different places, that can't be. So this is not a function. Okay, and it's not a function because of that -3. The -3 went to two different places. Okay, is that easy enough to see? So, if everything in the x just goes to one y, they can all go to the same y. It doesn't matter, as long as each person in here only goes to one place. This one, he's going to two different places. That's impossible. That is not a function. I shouldn't say it's impossible. It's impossible in a function. It means it's not a function anymore. Okay, so there are different ways to represent this though. So this was an example of mapping diagram. You can do the same thing by just listing the coordinates. Because each of these represents a coordinate, right? -3 went to 6. That's a coordinate. -3, 6. 7, -9. There's another coordinate. 0, 6, 1, 1/2. So you could I could have asked you the same exact question with the same exact points. So let's do that. Does this represent a function? And usually we'll put it, so I'll just list them. -3, 6, 7, -9, 0, 6, and 1, 1/2. Well, we already know the answer, right? Is this a function? Yes, because I had it here in a mapping diagram and the answer was yes there, so it's going to be yes here. I didn't change anything. But you can see each of my x values only goes to one y value. So that one is a yes. Let's do the same thing with our other example over here and see what that looks like. Okay, so we had -3 went to a half, but then -3 also went to -9. Then we had 7 going to -9. We had 0 going to 6, and we had 1 going to 6. Bless you. Is this a function? No. And the easy way to see, imagine I didn't have the mapping diagram and I didn't know that already. Look at how the x's repeat. That's your tell here. If you see any of the x values repeating, it's got to be a no because they're going to two different places. I don't care that the y's repeat. That doesn't break this as a function. That doesn't matter. See up here? See how the 6 is repeated? That didn't matter. It's the x's that repeat. Okay, so I'm going to say no because the x's repeat. No, x values repeat. Does that make sense? Is everybody okay? All right, there's a couple of other ways to test for functions. Some of them are kind of fun, I think. And one of the ways is if you have a graph. So if you want to just sketch a graph for yourself, it doesn't have to be too accurate, but try and put your dots where I put my dots. Let's say I had a dot here, 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 and here. You can tell at just a glance if that is or isn't a function. Does anyone want to guess which one it is? You think it is a function? You think it's not a function? Raise your hand if you think it is a function. Raise your hand if you think it's not. Okay, we're on the fence. Well, here's the easy way to test. You can't have any two that are on top of each other vertically. So if I look in a vertical line, do any of them, they don't overlap each other. So this one is a yes, this is a function. Yes. This is really something called the vertical line test. So I'm going to say passes vertical line test. So let me explain the vertical line test a little bit better. Basically what you do is you take, oh how convenient that I have this nice straw, right? You pass a vertical line along your graph. If it ever hits more than one time, it fails. So see how there's never more than one dot under my straw at once, right? If I ever had two dots under my straw at once, it fails. This one passed. So it's always a vertical line. So let's try one more and see what you think about this one. What if I did here, 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 and here? Is this one going to pass or fail? It's going to fail because right here you'd have two dots under my straw at once, right? Everywhere else is fine, but if there's anywhere on the graph that fails, the whole thing fails. So this is not a function. I'll even circle where it fails if that helps. It's these two. You can do the same test if it's not dots, but it might be like a curve. So for example, say you had something that looked like that. If I pass a vertical line along, I should have done the axes in a different color, or maybe the graph in a different color. Hold on. See how nice this is? And you guys laughed at me last semester. Look how nice. All right, let me do it in this color. Okay, so oh, you can't even tell that it's a different color, really. Can you? Can you tell that it's red?
Yes.
Oh, sorry. Doing my best. Okay, so that red curve, right? The straight lines are just the axes, so you ignore those. If I pass my straw along that red curve, does it ever hit more than one time? No. So that passes, that is a function. Yes. You can put it, actually, if you could give Mrs. Dalton that. Oh, okay, she said put it in there. Would a circle pass a vertical line test or no? No, it would fail, right? I'll even draw you one. So if I looked at a circle, the circle's going to fail all over the place as I pass that vertical line. The graph is hitting twice on that straw, basically all over the place. So that would be a big no. That is not a function. Okay, does all this make sense so far? There's one more little piece. Oh, by the way, this material that we're talking about today is not on your quiz tomorrow. So it's just everything we've done up until this. Because when you're done with your quiz, I'm going to have you do more practice on 6-4. Because there's kind of a lot in here. Okay, we only have one more little piece left, but it's an important piece. Okay, so the next little piece we need to talk about is evaluating a function. Now, we were doing yesterday, I would give you some sort of an equation, right? That equation might look something like this. Y equals 2x plus 3, right? There's something called function notation. It means the exact same thing as this, but it's written differently. And it takes a little while to get used to it, but once you get used to it, it's actually super helpful. Okay, so bear with me at first that I know it's weird and you feel like, why would I ever write it this way? But it will come in helpful later on. Okay? Okay, so here's how you write this in function notation. Same exact equation. You ready? Watch. What? What the heck is that? Let me explain, okay? So this does not mean f times x anymore. Another thing, remember I was saying how range, we had the word range meant different things depending on what you were doing? Same kind of thing here. The notation is different. This, up until now, that meant f times x, right? Doesn't mean that anymore. When it's written in this way, it's function notation. So this first letter right here, that letter is literally just the name of the line. That's just what I'm naming this function. Because I might have more than one function that I'm dealing with at a time. So I need some way to tell them apart. So instead of calling it function 1, function 2, function 3, I just give them a letter as a name. So I'm going to call you f, and it's f for function. We're not that creative, right? But it could be any letter you wanted, but usually we use f. So, hey, you're going to be function f. If I have another function, I usually call it g, just because we go alphabetically after f. If I have a third function, I'm going to call it h. That's all that is. So this first letter is just the name of the function. It just tells you which one you're using. So if I had f, I know, okay, I'm dealing with the f function. And then this thing, it does not mean f times x, right? The way that you read this out loud is actually f of x. What? So let me mark that. This thing right here, that whole left-hand side, you would say it as f of x. I promise you'll get more used to it the more you see it. Now here's what's so cool about this. I can take the function and let's say I wanted to know, okay, well what's the value of that function when x is 7? Or when x is 3? Or when x is 9? I can very easily find that answer. All I do, so let's say I wanted to do find f of 7, I said, right? That's how I would write it, first of all. So this is me just saying, hey, take 7 and plug it in for x. That's all that means. Take 7 and plug it in for x. Okay, so let's see how that looks. Instead of writing 2x plus 3, I'm writing 2 times 7 plus 3. So that's just 14 plus 3, 17, right? And you're done. You don't do anything with the left-hand side. It just stays. It just stays f of 7. You do not, and this is a big deal, you do not then go in and divide both sides by 7. Because remember, that doesn't mean f times 7 anymore. You leave that whole left-hand side alone. You just, whatever is in the parenthesis, you plug it in for the variable in your equation. And then you just solve. All right, this might make more sense if we practice a couple. So I'm going to give us some functions down here. So let's do a new f function. Let's say f of x is x minus 3. Let's say g of x is 2x, and let's say h of x is, oh, I don't know, how about x squared minus 1. Something like that. Okay, now watch this. Let's say I gave you some problems to do. Let's say I wanted you to do f of, hold on, f of 8. And then I wanted you to do g of 8. And then I wanted you to do h of what? All right. And then let's do a problem 4 over here. Let's say I wanted you to do, I'm sorry, you can't even see them. Let's say we did g of negative 1. Let's say we did f of 0. Let's do h of 2. That's enough for now, and then maybe we'll try some after we get these. Okay, so these are all different problems. So here's what we're going to do. When I want to do f of 8, that says to me, because I have the letter f there, that means, oh, I'm going to use this one. So all I have to do is put the 8 in for x and do 8 minus 3. So f of 8 is just 5. And you're done. That's all you do. You only handle the right-hand side. You don't do anything on the left. So go ahead and see if you can figure out what g of 8 would be. Does everybody have that answer? What's the final answer? Dylan, right? 16, that's it. G, so that tells you to use the g function, and then I'm just going to replace that x with an 8. So I'm just going to do 2 times 8. So g of 8 is just 16. H of 8. Who thinks they have this one? Ariel? 60 what? 63. I agree. H of 8, hey, that's because there's an H, it tells you to use this one. So now you just want to replace the 8. So you're going to do 8 squared minus 1. Do you see that? Does everybody see where this is coming from? So now, H of 8, I just have to do the 8 squared minus 1. Well, what's 8 squared? 64, right? Because it's 8 times 8. So 64 minus 1, 63. Is this kind of making sense? Okay, try 4, 5, and 6 if you haven't already. Okay, g of negative 1. Pablo, what'd you get? Perfect. G, so I know I'm going to go here. I just need to do 2 times negative 1. So g of negative 1 is indeed negative 2. F of 0, how about that? It looks weird, but what is it? What do you get as an answer, Olivia? Perfect. I'm just going to go to the f function, and I just plug in a 0. So I do 0 minus 3. That means f of 0 is just negative 3. And last one, h of 2. Olivia, you got the answer there? Positive 3, you got it. Go to h, plug in a 2. So that's 2 squared minus 1. H of 2. Remember, 2 squared is 2 times 2, which is 4 minus 1 is 3. So, is this all right? It's weird at first, right? But once you get the hang of it, it's not so bad. So, I need to throw one more little tiny wrench into this. How do you think, let's see if I can squeeze it in over here. Yeah, let's just do this. What do you think if I said, what's g of w? What do you think that would be? Olivia, what do you think?
W like X.
Yeah. So what's your answer going to be? Remember what we did. Look at this one, right? I took whatever was in the parenthesis and I replaced x with it, right, Dylan? It's 2w, yeah. You literally just, whatever's inside the parenthesis goes in place of the x. So now it's 2w. Weird. I know it's weird. But if you get your mind wrapped around, okay, whatever's in that parenthesis, whatever it is, it doesn't matter. You're just going to plop it in place of that x. So try another one. What if I did g of, I don't know, how about 7y? 14y is correct. You're going to do 2 times, and then you're not going to write x. You're going to write whatever is in that parenthesis. So in this case, it's 7y, and it's multiplication, right? So that's how I get 14y. Isn't that weird? It's weird. I know it's weird. But whatever's in there, you just dump it in place of x. So let's do one more. What if I asked you to do, I'm going to squeeze it in over here, maybe down here. If I asked you to do f of, let's say, w minus 7. Well, just go to the f function, right? And I'm not going to write the x. I'm going to write, what do I write instead of the x? W minus 7, and then I do minus 3. I can simplify that answer now. What would that get me? W minus 10. Weird, I know. So we're going to practice more with this tomorrow after your quiz, but let's stop this there.